Today, we embark on an ambitious journey, establishing a truly closed marine ecosystem.
No external intervention, no added nutrients, just life finding its own balance.
The premise is elegantly simple: a self-sustaining microcosm, entirely cut off from the outside world, yet its inner workings reveal profound complexity. This isn't just a sealed jar, it's an intricate dance of life and death, where every single element must contribute to the dynamic balance of the whole.
Prestigious. For this experiment, we carefully selected a community designed for self-sufficiency, a tiny ocean world.
Our primary inhabitants are detritus-eating sea snails, nature's cleanup crew, crucial for breaking down organic matter, keeping our intricate ecosystem pristine. Diverse phytoplankton, our primary producers, form the food web's base. These microscopic organisms convert light energy into biomass, vitally fueling the entire system. Their robust presence provides oxygen and food. These foundational elements establish our tiny ocean world's balanced ecosystem, crucial for its survival. Day 1, the tank teemed with new life. Dr. Vance observed, through clear glass, snails exploring the substrate, their tiny tentacles gently sensing their new world. Now, we let nature unfold, he concluded. The true test begins as these organisms adapt to their new, isolated reality, facing their ultimate challenge. Oxygen levels are critically dependent on the phytoplankton's photosynthesis. Any disruption risks compromising the entire delicate aquatic environment, a precise and vital balance. This is a period of silent observation, allowing the nascent ecosystem to find its footing, beginning to forge its own destiny within the confines of the glass. The ecosystem was clearly self-regulating, pruning initial diversity and favoring the most robust and adaptable individuals within its unique, isolated confines. Despite initial stability, internal struggles emerged. Dr. Vance observed smaller snails succumbing, their empty shells a stark consequence of intensified competition. These empty husks were a natural yet stark consequence. Limited resources and intensified competition highlighted the system's escalating challenges. His daily routine, once meticulous parameter checks, has shifted. Dr. Vance now observes subtle behavioral patterns and population dynamics.
He notes how the light catches the water, observing the slow, inevitable process of natural selection unfolding.
This isn't just survival of the fittest, it's survival of the most adaptable within strictly defined environmental parameters. A remarkable transformation. 100 days. A monumental achievement. A full 3 months without any external input, truly showcasing the system's resilience and self-sufficiency. At the 100-day mark, the closed-loop ecosystem showed remarkable stability. The water was crystal clear, reflecting perfectly balanced algal and bacterial populations within the tank. This miniature self-contained ocean, a simplified yet vibrant ecosystem, had truly achieved autonomy. It settled into a robust, self-perpetuating cycle.